Imagine for a moment that you're living in a world where yesterday, today, and tomorrow exist simultaneously, where the past hasn't vanished and the future is already happening. Sounds like science fiction, right? But what if I told you that, according to our best understanding of physics, this world is exactly the universe we live in? Time, that dimension that seems so natural and absolute in our lives, might just be the greatest illusion our human mind has ever created. Today, we're re-diving into one of the most profound and mind-bending questions of modern science. Does time truly exist, or is it merely a construct of our consciousness? We'll uncover how Einstein revolutionized our temporal understanding, why the universe seems to have a preferred direction in time, and explore the latest theories suggesting that time might be emergent, not fundamental. Get ready to question something you've always taken for granted. Hey there, cosmic explorers. Welcome to Cosmic Frontiers, where we unravel the universe's most fascinating mysteries. We're on an incredible journey toward 1,000 explorers, and today we're going to explore a frontier that challenges our very existence. To kick off our temporal exploration, let's rewind to what we consider common sense. In classical physics, developed by Newton in the 17th century, time was absolute and universal. Picture time as a gigantic river flowing uniformly through the cosmos, carrying everything in its current at the same speed, regardless of where you are or how you're moving. In this view, 1 second on Earth would be exactly equal to 1 second anywhere else in the universe. Newton saw time as a perfect cosmic ruler, measuring identical intervals for all observers. If you were in a spaceship traveling at high speed and I stayed on Earth, we would still experience time passing at the same rate. It was a comforting and intuitive view, one that perfectly matched our everyday experience. But that conceptual tranquility only lasted until 1905, when a young German physicist named Albert Einstein introduced an idea so revolutionary it still blows our minds today. Einstein proposed that time isn't absolute, but relative. And even more shocking, time is intertwined with space, forming a single entity called spacetime. Here's an analogy that might help us visualize this. Imagine you're walking on a beach, leaving footprints in the sand. In the Newtonian view, it would be as if the sand were infinitely rigid. Your footprints would not deform it at all. But Einstein discovered that spacetime is more like a giant trampoline. When you place a bowling ball in the center, it sinks down and deforms the entire surface around it. Mass and energy do exactly this to spacetime, curving it and, consequently, affecting how time flows. This means that if you're near a very massive object, like a star, time literally passes more slowly for you than for someone far away from that object. This isn't fiction, it's pure physics, and has been experimentally proven countless times. The clocks on GPS satellites, for example, run slightly faster than clocks on Earth's surface, because they are in a weaker gravitational field. But Einstein's relativity brought us an even more unsettling revelation about the nature of time. In special relativity, we discovered that events simultaneous for one observer might not be simultaneous for another moving relative to the first. This means the very notion of now is relative. Your now here on Earth might include events that, for someone traveling at high speed, happened in the past or will happen in the future. This discovery led many physicists to conclude that all temporal slices, past, present, and future, exist equally. It's as if the universe is a movie already fully recorded, and our consciousness is just a projector moving frame by frame, creating the illusion that time passes. But if all temporal slices exist equally, why do we perceive time always flowing in one direction? Why do we remember the past, but not the future? Why do we see glasses break, but never spontaneously reassemble? This is the question of the arrow of time, and its answer is intimately linked to a fundamental concept in thermodynamics: entropy. Entropy is a measure of a system's disorder or randomness, and there's an absolutely inexorable law of nature. In an isolated system, entropy always increases or, at best, remains constant. It never spontaneously decreases. It's as if the universe has an inherent preference for messiness. Let's use a domestic analogy. Imagine you have a perfectly organized room. If you leave it alone and just live in it normally, it will gradually become more disorganized. Clothes on the floor, books out of place, dust accumulating. The room will never organize itself. That would require external energy and effort. This is the behavior of entropy, always growing. In the context of the entire universe, this means the cosmos began in a state of low entropy. highly organized at the Big Bang, and since then has inexorably moved towards states of greater disorder. This progression from low to high entropy is what creates our subjective sense of the arrow of time. It's fascinating to realize that our memory also follows this direction. Remembering something is essentially accessing records of low entropy states that existed in the past. The future, being a state of higher entropy, is by nature more uncertain and unpredictable. Hence, we can't remember it. But here arises a deeply intriguing question. Is time a fundamental property of the universe, like electric charge or mass, or is it something that emerges from more fundamental processes? Some of the most advanced theories in modern physics suggest that time might be emergent. Carlo Rovelli, an Italian physicist pioneering loop quantum gravity theory, proposes that time doesn't exist at the most fundamental level of reality. In his view, time emerges only when we consider macroscopic systems with many particles. It's like temperature. You can't talk about the temperature of a single molecule. Temperature only makes sense when we have a large number of interacting particles. According to this perspective, at the most fundamental scales of the universe, at the Planck scale, where the very notions of space and time become fuzzy, there is no time flowing. There are only changes, correlations between different states of quantum systems. The time we experience would be an emergent statistical property, like the heat that emerges from the chaotic motion of molecules. Wheeler and DeWitt, in developing the fundamental equation of quantum cosmology, arrived at a surprising result. Their equation does not explicitly contain time. It's as if, at the most fundamental level, the universe were eternal and unchanging, and time emerged only when we consider parts of the system in relation to other parts. This idea is strangely comforting and terrifying at the same time. It means that, in a sense, all moments of our lives, our childhood, this present moment, our eventual death, might exist eternally in the fundamental fabric of reality. There is no absolute creation or destruction of temporal moments. Some physicists, like Sean Carroll, propose that time emerges from quantum mechanics through a process called decoherence. When quantum systems interact with their environments, they choose definite states, creating a sequence of events that we perceive as temporal. Time would then be a consequence of the loss of quantum information, intimately related to the growth of entropy. There are also theories suggesting that spacetime itself might be emergent. The AD-CFT correspondence, one of the most important discoveries in modern theoretical physics, shows that a theory of gravity in one space can be completely described by a quantum theory without gravity on its boundary, a theory that doesn't need to include time as a fundamental dimension. This leads us to a truly dizzying possibility. Perhaps we live in a holographic universe, where all the information of our three-dimensional cosmos plus time is encoded on a distant two-dimensional surface. In this view, time would just be an emergent way of organizing quantum information. But what about our subjective experience of time? Why do we feel this temporal passage so vividly if it might be an illusion? Neuroscience suggests that our brain constructed a temporal model of the world to survive and navigate reality efficiently. It's an evolutionary tool, not necessarily a direct perception of the universe's fundamental nature. Think about it. Our ancestors needed to predict when fruits would ripen, when predators would attack, when winter would arrive. A brain that constructs a coherent temporal narrative had an evolutionary advantage over one that only perceives timeless correlations between events. It's important to mention that these ideas about the emergent nature of time are still speculative. Our current theories, general relativity and quantum mechanics, still treat time as fundamental, albeit in different ways. General relativity views time as a geometric dimension of spacetime, while quantum mechanics uses time as a parameter to describe the evolution of systems. The great challenge of modern theoretical physics is to unify these two theories into a quantum theory of gravity. And it's possible that, in this unification, we'll discover that our current understanding of time is incomplete. Perhaps time is stranger and more wonderful than anything we can imagine today. String theories, loop quantum gravity, quantum information theory, all these frontiers of physics are exploring the possibility that time, as we know it, is just the tip of a much deeper and more exotic conceptual iceberg. Some proposals suggest that time might have multiple dimensions at fundamental scales, or that it might be discrete, made of indivisible units, rather than continuous. Other theories explore the possibility that there might be regions of the universe where time flows in different directions, or where multiple temporal arrows coexist. There is also the intriguing possibility raised by quantum mechanics that time might be affected by quantum measurement processes. If reality is fundamentally quantum, then perhaps our conscious observation of the world plays a role in creating the temporal experience. Recapping our journey through this temporal frontier, we discovered that Newton's absolute time was replaced by Einstein's relative time. Intertwined with space, we saw how the arrow of time emerges from the inexorable growth of entropy, and we explored modern theories suggesting that time might not be fundamental, but emergent from deeper quantum processes. Perhaps the most profound lesson from our exploration is that the blessed universe is far stranger and more wonderful than our intuition suggests. Time, that dimension that seems so natural and obvious, might be one of reality's most sophisticated and beautiful constructs. And this leads us to a fascinating cosmic reflection. If time is emergent, if all moments exist eternally in the fundamental structure of the universe, then every instant of discovery, every moment of wonder before cosmic mysteries, every connection we make as explorers of the universe, all of this can be a permanent and precious part of reality's eternal tapestry. This shouldn't make us feel less special or less important. On the contrary, it suggests that our consciousness, our curiosity, our ability to contemplate these deep mysteries might be one of the most extraordinary ways in which the universe comes to know itself. Cosmic explorers, here's my question for you in the comments. If we definitively discovered that time is an illusion and that all moments exist eternally, would that change how you live your lives? Would it make every moment more precious or less significant? And since we're exploring the most mysterious frontiers of reality, what universe mystery do you want me to talk about in the next video? Black holes and lost information, the nature of consciousness and the cosmos, the multiverse and parallel realities. Leave your suggestions in the comments. You're the ones guiding our journey of discovery. We're on an incredible journey toward 1,000 cosmic explorers, and each of you makes this adventure richer and more fascinating. If this video expanded your horizons on the nature of time and reality, join our crew by clicking subscribe. Like this video if it made you question something you always took for granted, and share it with someone else who loves exploring existence's deepest mysteries. In the next video, we'll dive into another fundamental mystery, and I can promise it will be equally unsettling and wonderful. Until then, cosmic explorers, keep looking at the stars and questioning the nature of reality. The universe is full of surprises waiting to be discovered.